tonight we do have a very specific topic in mind. We're going to be looking at recurrent neural networks in the context of this self-driving car model. So really what that means is you want to be able to look at the current frame and a couple previous frames to figure out which way you're supposed to be steering. So maybe you get a sense of more of the total environment where you've been. Hopefully is going to tell you where you're going. You could do this very directly by just including those extra frames as extra pieces of your data set to use. That is one approach. That just means that many more features and convolutions at the beginning. These could just be like extra channels even, I guess. Yeah, I guess you could just do it that way. Oh, I didn't think about that. Anyway, you could just do extra channels. So you'd have 6 channels at the beginning rather than 3 if you had looked back one frame and 3 times as many more for every frame you look back. Or you can use what's called recurrent neural networks. So somewhere in the middle of my neural network, or maybe at the beginning, or wherever, you use this recurrent layer, which says, hang on, whatever we're doing, keep an extra piece around and look back. Save those features. The next piece I'm going to look at, I'm going to need those, and I want to look at them and know what the heck it is that I'm doing. So in this case, I want to start with simple RNN, just save those features. And this is after I've done all the convolutions, and you just happen to add in the speed and acceleration at this point. I'm saying, all right, that's a good place to add in. There's 258 features at this point because there's 258 features from the image, as well as the 2 basic inputs. So that's all that we got. Hopefully it's not too wild. I've been fiddling with this for a little bit now, and I just got the model to actually compile, essentially. I don't know that it's actually working correctly, though. So what I have is I have some old code of mine that I worked on my font recognition project. There I looked at blocks of 8 letters, and I was trying to use, based on the previous letter block and this letter block, try to figure out what the font is. That sort of worked there. They were using this long short-term memory, which is another kind of recurrency that's a little more complicated I don't want to get into. So I borrowed some of that code and some other code. Essentially you have to reshape it. It's expecting not just, oh, you've got these 256 features. It's sort of expecting, oh, what are the other inputs that you have? So I'm going to see how this goes. That's all I'm going to say at this point. But let's compile the model. I'm also not going to use every single piece of data I have, because I'm sure it's going to take a while just to get this model to figure out what it's doing. Because if I did that, we look at all the data, I've got 36,000 data points, which is a few more than I need, just for the purposes of debugging my model, essentially. We're just going to run a few of these, nothing fancy. I'm not even going to try to train this. Not going to save the weights, anything yet. Nothing like that. I just want to run, will this model even run? That's always the first question. Will the model even run? So again, we're doing recurrent neural networks. It's got to compile the model first. Meaning some feature we're computing in the middle of our computation will be used in the next. Oh shoot, I should not have shuffled that. That was a mistake, serious mistake. So some interior features you're computing for a given frame, you will use those features again in the next frame. And the way this works is if you're looking forward or back a particular number of frames, you can sort of very easily just, oh, let me keep those features around, and they just sort of, in the background, they're just getting added back in. But if you're using TensorFlow, it actually has a dynamic RNN, so you don't sort of have to specify this block size. I'm just going to kill that, because I did that wrong. I've used that once or twice. That's actually a really nice thing, because I always mix myself up. I'm like, well, what's the block size? What if I got a variable length sequences, all this, that, and the other jazz? Like you can sort of say, oh, I want to look back 8, I want to look back 10, whatever, this, that, or the other thing. Right now, I just want to see, will this run at all? That is always the first step. Will this actually run? You know, I find on the first 1 out of every 100 trials, things will compile and actually run correctly. Maybe about 1 in 10 I will compile without any seg faults. or anything like that. Or 1 out of 10 it'll compile. And maybe half the time when I first compile there's no sig faults, I'd say. But that's just my style of programming. I'll let the compiler tell me, oh, you did all these horrible things wrong. Okay, and I can go back and fix them all, and then by the time I'm done, it's all working pretty nice. These model compilation times, though, these are killing me. It's absolute murder on the stream. There it goes. Okay, it's doing something. It's saving. It's just looking at 1,000 frames just to see, like, yes, am I doing something? And it's going to take like 10 seconds, maybe 12 seconds a frame. 12 seconds an epic here. 14. Okay, that's not too bad. And like, don't trust these errors at all because, of course, it's all just on a very, very small number of frames. So yes, you might say, oh, look at that validation squared error. That's already almost as good as my big other model. No, it's not. Don't believe it. Don't believe their lies. I don't even think I want this to go for 5 epics. I just wanted to see if this was doing the right thing. Alright, just kill that. Alright, model. So the question is this actually doing what I want it to do? I'm not sure that it is. That's the thing. I'm not sure that it is. Alright, I've got 258 things. I'm connecting to 256 things. And they're saying that's this many things. Is that right? That's twice as many things. Which, to me, that suggests that that's right. You know, plus a bias term. Plus 2 bias terms? Oh, not plus a full bias term. It's not quite 2 full things. Why is that? Oh, I see, because I'm just getting 256 from the previous iteration. So it's 258 times 256 plus 256 squared. 131584 plus 256, 131840. So just to walk through this math that I sorted out here, I've got 258 input features. That's things we've computed from the frame of this time step and the 2 inputs, the 2 real valued inputs, the speed and the acceleration. So I've got that many nodes sort of going into this here. And I'm computing 256 features. That's how many output nodes I have at this layer. So if this were just a normal layer, you would have sort of this 258 times 256 number of parameters that you'd have. Plus, you would probably have 256 bias terms. A bias term for every output node, essentially. But here we also have, this is a recurrent layer, so we're taking each of those 256 outputs, and in the next frame, it will be like another feature that's getting added in here. So really, you can think of this as we got the 258 regular inputs, plus the 256 inputs from the previous, plus 256 outputs from the previous frame. Those are going to be inputs into the 256 nodes of this frame, plus 256 bias terms. And that's how you get that number of parameters, which is pretty large now that I'm looking at it. And that might explain why going through 1,000 data points takes 15 seconds, which is really, I'm not a fan of. 66 milliseconds a frame, I guess I can live with that. Oh no, it's 900. 60 milliseconds. No, wait. 15 seconds divided by 900. My math is really off. 160. No. That's just 16 milliseconds? Not that bad. Not that bad. So I'm actually amazed that I believe that is working and doing the correct thing, which always blows my mind. I never expect these things to work right. I never expect them to work right. Alright, so question 2 is, can we make a model like this start to do something reasonable? I'm going to keep all these convolutions. I am going to drop the number of these things to like 64. I want like next to none. And I'm going to kill a lot of these inner layers here. This is just the RNN steer I made a new script file just because that's what I like to do. 256, yeah, sure, 256. Like this is going to be a severe cut down on the size of the model. You look, come back and look over here. Most of the parameters are in this RNN layer, and the one right after it, and it looks like this last convolutional layer. Right, and these convolutional layers, they're getting bigger and bigger in number of parameters because we're increasing number of kernels. So there's sort of no getting around that. But if I can cut down the size of this and the size of this, that'll help out on the model size quite a bit. Yeah, you know what? How low can you go? That's a question we want to ask ourselves here. All right, so let's make a new model that's a little bit smaller. Again, we'll keep the convolutions around. I like the convolutions. It also means I don't have to recompute the size there. I'm doing something terrible because like I'm hard coding the size of the convolution sort of. Although I wonder, can I say -1? Will it just reshape to the right thing? We're going to find out. You flatten, you do this, and you reshape. No, we cannot do that. Bummer. Bummer. Alright, 258. 256 plus 2. Just so I know. 64 RNNs, RNN parameters, RNN, recurrent neural network nodes. Alright, those are good. Actually, let's leave that as is. We've already got our data. We definitely don't want to shuffle right now. Just keep this around. This. Verbose. Num epic is just going to be 1. Just to see. Make sure that this runs. And then we'll think about running it for a little longer. I want to see how long this takes, first of all. The convolutions will take a significant amount of time. And of course the compilation, which involves the convolutions, also takes a significant amount of time. Well, that wasn't as bad. Alright, so that's going to be almost the same amount. I guess these convolutions really are what dominating my the time for my model here. That's interesting. I wouldn't have expected that. So that takes the same amount of time. That's interesting. I would not have expected that. So can I get away with a smaller number of convolutions to speed up my model significantly? Maybe I can. Yeah, let's try it. Right now, I'm just worried about, not worried. I just want to do something quickly to see like, does this work? Is the sort of operative thing. Does this work at all? I want 64, I want like 32. Yeah, that makes more sense. Let's do that. Drop L1 is not defined. Huh. I guess I don't do a drop in L1. I'm not actually dropping anything right now anyway. I should do a drop on L1 though. There we go. Now, run this convolutional layer, flatten that bad boy, and now I have to remember how to get these sizes in correctly. Because you can't just look at M. M doesn't tell you the information you want to know. I swear I've looked at this before. I swear I've looked at this and I just do not remember how to extract the sizes from a node in a graph model in Keras. I swear I'd done this. Maybe I had not. Maybe I had fought with it and decided. If anyone knows offhand how to get the sizes out of a graph model in Keras. That you're not in a model yet. You're just in a node that you've described. Which maybe you can't. Because maybe it's oh, that's true. You probably... Can I? No, because I've got frame in here. So it knows. It's like, I don't want to do the math. I don't want to sit here and have to do the math and screw it all up. Because I'm computing, yeah. That's not something I want to do, really, at all. Although, does Keras have a thing to, like, just compute that? That would be an interesting question. If it could, for me, compute the size as like another layer operation here. And then like this reshape takes that as an input. That'd be really weird. I want to see if I can do that. I get easily distracted by locally connected layers, core layers, recurrent layers. It's a locally connected layer. Some of the colors, the weights are unshared. No, that's not what I want at all. Model, functional, excuse me, the functional model, not the graph model. But I don't want the layer yet. Not what I want. Keras layer. Yeah, you can say layer.input shape and output shape, except you can ask for that. That's just a shape object. Yeah. It doesn't give you an actual layer. Yeah, it's like a Theano object is the problem. It's not a... So maybe in TensorFlow, maybe you would get this information, which is kind of interesting. Well, it's going to be 2 plus... What have I got here? 64 things. How big are my objects? 64 originally. 64 by 64. So I'm computing 64 by 64 things times 24. And on those 64, for the question from the audience, for the RNN, do we always look at one previous time step, or can we do more? You can do more. In this instance, I've chosen to just look back to think about one, just to get it started, but you're right, you can absolutely, in your RNN model, you can say, hey, whatever features I've computed at this point, give me several back that are like 2 or 3 or however many back. And we will look at that in just a second, how many back to consider. There's definitely a way to do this. And I just, for the life of me, I don't remember. On the other hand, you can also consider that you're sort of already including that information. Because if I look back one round, in that round, I looked back in the previous round, and that helped me compute whatever these things are. So in a certain sense, you're getting that information. You've got a continuous chain from the start to the finish. But having it directly can be valuable as well. But I would like to get this stupid shape thing working. I don't know why I cannot for the life of me remember this. Is there just a shape layer? That would actually be really interesting. Keras shape layer. Let's find out. Keras shape layer. What do we got? What do we got? Keras get shape layer. But it's like, I don't want to get the layer of a shape. I need a layer that tells me what the shape is. Hidden layer representation of a given data. That's not exactly what I'm looking for. Do some Theano stuff. Need to compile your model first. Right. Compute shape maybe is what I want. Compute shape. Guide to sequential model. We don't have a sequential model. Why do I get a LSTM RNN input shape error? Oh yeah, that's a universal problem. Getting the shapes on these RNNs to work right. That's quite an issue. You can try to use it without specifying. Let Keras do the work for you. Oh yeah, well that's a good idea. Did I determine that? I did not determine that I could. What if I just do this? What is M? I made M. Can I do that? No. That ain't gonna work. None? No. So I know it's not 258. It's gonna be more than that. What? No. No way. That's gonna yell at me, but I'm just gonna use this to get the output summary. It's... Damn. Really? Graph disconnected. Cannot obtain value for yada 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 yada. Alright, let me remake that. Let me just remake the whole graph. That'll simplify this a little bit. Oh jeez. Did I not get a new one of those real inputs? Ah, heck. Alright, one more time. One more time, this time with feeling. Right? Yeah. And then you try to get some output. Right, that's an expected error. That's totally fine. I just want to pretend for a second that M is here. We just want to look at this. That's summary. That's such lies. You worked earlier. Graph disconnected. Right, let me just kill this. There's something wacky going on. Something wacky going on. That definitely worked earlier to just inspect the model and see what the heck was going on. But it did not want to play nice today. So turn it off, turn it back on again. Is sort of the solution that I have right now. Flat is not defined. What is this? What is this garbage? What are you complaining about? Drop L4. Arrgh. Why didn't I notice this earlier? Curse you, curse you. Drop L1. Alright, so that was the problem. I was referencing a layer that no longer existed. Or that existed but was not part of anything else, which I should have inferred from what the issued problem was. Yeah, it should have, instead of saying, hey, steer out, it was saying, hey, you got things that don't jive. So on the last layer, I've got 16,386, which is going to be 2 to the 15? No, 2 to the 14. Bam. So that's cool. That's a lot of parameters, though. That is a lot of parameters. How big a thing is this? Oh my gosh. All right, I'm wussing out. Oh yeah. No, I meant that to be smaller. 100%. There we go. Much better. All right, and now here's the model. There we go. Yeah. 8194. That's still, well, no, that makes sense. I cut that number in half, in fact. That's 2 to the 13, isn't it? Plus 2 more, right. Yeah, I should have seen that one coming. Should have seen that one coming. Okay. 2 to 13 plus 2 then. It's 2. Perfect. So we still have a killer number of parameters here, but overall, there's only 20. You know, well, watch this. We'll do that, do this, play the model game again. Except now we're outputting R. You're going to see the explosion in the number of parameters. Yeah, went from 20,000 to 500,000. Just because you've got so much. Every one of these nodes has to go to every one of these, times 2 basically. It's a mess, it's a mess. You have 8194 plus 64 times 64 plus 64 more. Yeah. So it's a lot. Man, there's just like no getting around it. Or you spend more time doing computations, or you spend more time with more parameters. Let's see what the damage here is. I do need to read in my data again. So it goes. And let's just see what it says in one. If it just runs, maybe we'll let it run for a little bit. See how long this takes. All that effort, and I bought myself, it was 12 seconds before. Now it's 9. And I'm definitely not having appreciably. The model's not actually really smaller, is it even? This one is 500,000. Before we were rocking. See if we still have it. We were rocking a little under 500,000. So the model has actually gotten bigger. Despite our best efforts, the model has somehow gotten bigger. There's more parameters that there's a good chance it will take even more training to get going. And we shaved 3 seconds off the epic time. That's just misery, man. Misery. All right, I'm gonna undo all that garbage. That's what I'm gonna do. Do a bunch of undo. There we go. Much better. I'm gonna put this drop back in here though. Definitely putting that back. L1. This will be drop L1. In case I do want to add dropout training again. Don't necessarily have to, but that is the nature of the beast. Dropping this to a more reasonable number of parameters, well, that should help, right? Let's keep all these a little bit smaller. Not that that's a big deal. Alright. I want to train this model for a little bit of time. Another question. August says, I remember with the LSTM I needed to use time-distributed convolutional. I guess that is instead of doing reshaping. Interesting. I haven't seen time-distributed convolutional. And I've used LSTMs before. So maybe that's something I should take a look at. And that might be if you want to have like your inputs be right where the recurrence is. We can take a look at it while the model is running. That because LSTMs are going to be like the next thing we give a shot at. All right. Just one run one epic just to make sure it's doing something. Got to compile the model. It'll be 13 seconds. All right. Yeah, I'm amazed that's just not that serious. Let's see. 10,000? Yeah, 10,000. Let's do more data. And let's get that going. So it'll take 10 times as long, so a minute 40, a little under 3 minutes for one epic, which is a while, but not forever. Although, wow, for all the data, it's going to be like 9 minutes then. Yeah, it sounds almost right. So let's take a look at this time-distributed convolutional stuff. And I'm guessing this is in Keras? Time-distributed. Hey, what do you know? Model A, sequential, time-distributed convolutional, input shape, sad face emoji. Oh no, that's just part of it. Let's take a look at this. I think probably an example here. So I keep chat open on a separate computer entirely from the one I'm using here, so I can't actually just copy paste. Perhaps this is something I should reconsider. Time distributed. There we go. Time distributed, not dense, convolutional. Actually, time distributed dense might be important. Time distributed is not in here anymore. Core layers. Let's take a look at time distributed dense. It's probably a similar kind of construct. Apply a same dense layer for each dimension, time dimension input. Especially useful after recurrent network with return sequence equals true. What does that mean? Time distributed. Oh, you can time distribute any particular layer you want. Time distributed wrapper. So if you have a convolutional layer, you can say time distribute this and then do the thing. Especially useful after recurrent network. Interesting. Why is that useful? Number of samples, the time dimension, the input dimension. That's actually kind of interesting. You say after. Like this, I assume that means more towards the output side. Is there... with return sequence. So what does return sequence do in a convolutional layer? Or not in a convolutional, excuse me, in a recurrent layer. To the internet. Let me kill some of this stuff. I was looking at some examples in Keras earlier. Return sequence. Recurrent layers, yada yada yada. So yeah, what does that mean? Whether return the last output in the output sequence or the full sequence. Right. Believe I understand that. Why do we return the last output in the output sequence or the full sequence? So right, that means I'm just going to get the current. I think I only want to output the current guy, using up whatever information we built up. I think if you do this time distributed thing and you say return sequences equals true, you sort of get the RNN output at every time and every time previous. So if you've got a fixed sequence length, you're saying I want to use these bunch of features we've computed at this point in the network. God, this thing hasn't even compiled. Come on, there we go. Oh, I need to enter. God, what an idiot! What an idiot! What was I saying? Yes, it's a matter of, do you want to have these intermediate features available, all of them sort of at the last time and like everyone previous to you, or do you just want the most recent? I think is what it's saying. That's my understanding. I don't find it weird that go backwards is an option. Unroll. Consume less. Oh, what's this? Uses fewer larger matrix files. This is running faster on CPU because memory is set to mem. Oh. Combine an input gate and the forget gate and output into a single matrix. This is cool. Must be shared for all gates, resulting in slightly reduced regularization. That's actually kind of cool. That you can say like which thing to optimize depending on what you're on or what you're limited by. That's super cool. That's a surprisingly small error. 10,000 data points, nothing to scoff at. Although we've only looked at like 4,000. Maybe these are particularly easy data points. Or maybe, as in case you haven't read the paper, recurrent neural networks, especially LSTMs, are unreasonably effective, if you're willing to believe that. Maybe this is the key that we needed to unlock this. They work really well in language type situations, where there is a lot of dependence from like one character or word to the next, and especially like this certain word with a word, I don't know, 10 words back or however far it's going to be. I don't think in this type of situation that's exactly what's happening, what's going on. Where I'm steering now does depend, in a sense, on where I was looking a second ago. But it's not the end-all, be-all. Okay, you got maybe a discussion, you got a good link to link us? Maybe we can open that up here. Alright, while this is running, let us try. You can see how slow my computer is getting. I really hope the stream isn't hung too much. Yeah, we're okay. 144 seconds, right on the mark. Mean squared error, pretty bad. Well, that's the nature of the business. This might be a particularly challenging 1,000-long set of the mean squared error. We don't know. If I ran it on the whole data set, where it will take, 9 minutes. Let me take a look at that. We have a GitHub link. github.com. There's a good chance I've even looked at this issue before. Keras/issues/401. Maybe not. Oh. Easy way to combine CNN plus LSTM. I've definitely looked at this before. I remember looking at this. Probably when I was doing the old, like I had a simple weather model or something, or even with the font recognition stuff I was looking at earlier. There's a straightforward way in Keras to combine a convolutional with distract features and then feeds into an LSTM. Read the documentation on the built-in reshape layer. Yeah, don't flatten the CNN outputs. Use reshape instead. Oh, interesting. Don't flatten them. Use a reshape. That's interesting. Maybe I need to look up the reshape layer. Reshape. Target shape. Reshapes an output to a certain shape. Well, in this case, I sort of have to because I need to get my information from this merged group. I guess I could reshape and then merge. Input shape. Arbitrary, though all dimensions of the input shape must be fixed. Use the keyword argument input shape, yada yada yada. output shape, batch size, target shape. This doesn't actually give us super lot of information. Like it's helpful that to mention, hey, look this up, but that's not full information on this. But I guess if you're doing flatten, then you should be using reshape in this instance, right? Because you need the sort of the number of times you're looking back, comma, how many things you're willing to consider, or how many features you actually have. Go to the page, where's info about, oh, just look at time distributed. Hey, that makes sense. Order of CNN layers interact with the LSTM layer. They need to be distributed across time. I've made time distributed versions of convolution interesting. And on this guy's GitHub repo. Do what you propose above as follows. Number of hidden, number of samples, number of time steps. He has like straight up, boom. Does a time distributed convolution. Does a time distributed max pooling, right? He's got his activations, time distributed flatten, and then he does the LSTM. Oh, interesting. Interesting. And num time steps is the number of like frames he's considering together at once. So every frame is going to get to look at like the previous 15 frames here. That's an interesting idea. And so this is using a special thing that this guy made. But now there's just a like time distributed wrapper you can call on things. We can maybe give this a try. Yeah, do a bunch of stuff, then call LSTM. Hey, you know what? Let's try it. Nothing to stop us from trying it. Where was time distributed? Time distributed. It's in core layers. Keras layers core time distributed. Not time distributed, then it's just time distributed. I hope it's in the same layer. Keras layers. Actually, let's get this bottom. Core import time distributed. So you're sort of computing all those things on it at once. Keras layers wrappers. Oh, thank you. There we go. Keras.layers.wrappers, import time distributed. Yes, that is what we run. Time distributed. And we sort of need to redo all these convolutions in this time distributed manner. Do I need to redo like my inputs too, I guess? I'll take a look at that stuff. Let's grab this. What is... Here we go. Input shape. He's doing some MNIST stuff. I see. Interesting. Or he's using 28 by 28 things, which are strongly suggestive of MNIST. Digit classification. Read above. Read above. There's more? Oh my goodness. This guy's going to try it. Able to exactly determine input. Permute. Reshape. Yeah, well he's just doing... Yeah, he's doing one channel. But what did I do? I used reshape. That's what I did, essentially. And I used several blocks. So I read in the old font recognition model I had, I read in every data point, or every 8 long stretch. Like, did its own convolution for every single one of those, flattened each one individually, and then I merged those together and reshaped them back into the proper shape that I want. So maybe this could have been consolidated. And then I did an LSTM. So I did something I think that was analogous, but this time distributed might have saved me a lot of effort in doing this project. So that's actually pretty neat. So I want to see what this does. If I can get this to work. And time steps. Yeah, let's take a look at that. I apologize if that wasn't the exact point you were hoping I would get, but that's now what I've gotten out of it. That's now where my brain is going. It says, oh yeah, let's try that. That sounds cool. It's the nature of learning. And time steps equals, I don't know, let's just look back 4. Just for the sake of argument. believe... Let's see if I can get away with this. Yeah? They use time distributed. They call it on the dense layer itself. But I want to see if I can get away with this. Alright, this thing is not doing terrible, in all honesty. Not doing that bad. So we do a bunch of this time distributed nonsense. And I should not use this flatten, or I should. Oh, what's going on here? Yeah, time distributed flatten, of course. Of course. Silly, silly. Time distributed flatten. I suspect like that, because otherwise you get this Theano object, and I don't think I'm going to be able to time distribute that. And then a regular LSTM type thing. That's just a little wacky. Throws me off. LSTM. There we go. In case I need the reshape, I don't think I will. Oh, I guess I need that anyway. And return sequences equals true. So hopefully this will save me from having to reshape all my input data, is really what I'm hoping to avoid. That would be nice. Right, return sequences equals true. He's doing 256, that's fine. We'll do, you know, like 64. That sounds good to me. I like 64. 64 is good. Gives me like the 2 to the 14 parameters. Yeah, everything's good then. Everything's real good. I'm like just waiting for this to finish its last epic there. I want to see after 5 epics, which is an amount I've trained others. Although this is on less data, so maybe it's not that bad. Then I'm gonna need time distributed dense layers, which is interesting to me. That is the thing that you need. I guess just grab all this stuff. Doink. It's so cool that there's just a wrapper you can use to say, hey, time distribute this. Alright, what's the final tally on this was 0.015. Validation 0.01, yeah. It's not terrible. It's actually not too bad for... Takes a little while to compute. And like with all the data, that's going to be like times 9 or times 10. So that's a while. It takes a long time. Need to reshape the data, unfortunately. Oh no! Well, I have to reshape the data now, so that's the nature of the business. How does he get away without reshaping? Or maybe if I scroll down, I'll learn about the reshaping. Invalid shape, yada yada yada. 5 dimensions, yada yada yada. Yeah. Man, the chat here is really terrible at rendering the code that happen to have things that like qualify as emojis. I'll have to see if there's a setting to like turn that off. I'd rather just have like code be code. Okay. So time distributed. I want to see if this stuff even see if this stuff even works. Let's do that. It's my number of time steps. Good, good. Oh, I need to say how I'm distributing this, right? Time distributed. And it's like I need an input shape or something. That's going to irritate me. Definitely. If I can get away without specifying the input shape. Exactly, if I can just say like the number of time steps. Oh, come on. Why? Why do I have to explicitly say just that one? Yarg. Subsequent layers, no need for input shape. Yeah, figures. Alright, that's not a big deal. Not a big deal. This is going to be... Oh, and I should do this on the inputs too, shouldn't I? I really should, shouldn't I? Maybe I can get away with it. we're going to see how this interacts with the graph stuff. Input shape equals oh, maybe I don't have to do that here, actually. I'm willing to bet I get away if I just call time distributed on my inputs. Ho ho ho. And that's where I have to declare my input shapes to begin with, so. Doink. Input shape equals n time steps, comma 2. I think that's right. Yeah. Let's do this one then. Let's see, this is going to take a little time just to implement all these. I might get hungry and have to stop and eat dinner first. We'll see. Input shape equals n, comma 3, comma n rows, comma n calls. Alright, so I believe I'll have to mark it for both of these. Does this work? TensorFlow is no object uses learning phase. I don't know what that means. What is input? Oh, because that's a tensor object, not a layer object. And I was hoping to get away without having to do that there. Input used to instantiate a character's tensor. Yada yada yada. So what's real in, I guess? Real input. Oh, that's cute. What kind of thing is it, pal? Yeah, that's just a Theano thing. Okay. So unfortunately, I don't think that goes there. We're going to learn if this works in the typical setup here. Equals n time steps, comma 3, comma n rows, comma n calls. Let's see if that works. Just do that, normal, that's normal. What happens here? Good, that did something. Image must be a 40 tensor. Right. It's conv 1 then. Oh, so maybe it's here that I need to do it? So time distributed in a graph model is the question. How do I get that started and rolling? Here, these are all sequential, I believe. Yeah. Is it in here? Time distributed dense. Yeah, because typically you have, like, if I use it just like a dense model, a dense layer, you would do something like this, and then you call it on whatever blob you have. It should be like this. Also, I'm going to clean this up a little bit because it's driving me crazy. Trying to see like what's what. That does run, it's just not right. Image must be 40 tensor. Conv1 dot shape. What are my options? Get shape. Input shape, output shape. Output shape. There we go. Layer has never been called unless it has no defined shape. Yeah, that's what I thought. Let me look-see back at this thing again. So this is looking like I'm going to have to muck with my input, just like I did in the way I did it in the font model. Which is, I'd like to avoid that, because that's sort of like multiplying my input, or I'm doing crazy things when I'm doing the input. And I was hoping this would take care of that for me. But are they showing the actual... Of course, no one shows the actual training call here, nor do they have example data. Maybe it's in here, even though this is 8 months old. TensorFlow, I really shouldn't have server backends, but whatever. Installation instructions, layers, time distributed, this thing, that thing, removed. Alright, what's an extra? Extra, read all about it. Time distributed flatten. Ugh, trying to read like the source code to understand what's going on is not somewhere you ever want to be. Time distributed conv 2D. I mean, so you don't have examples in your own. An example. See here. Well, there we go. That's good. That's what I want to see. This is actually exactly what I want to see, I think. Well, almost. It's not a fancy thing. Simple model can do. What are you trying to do? Creates training vectors of varying numbers of images in them and trains the RNN sequences to predict the sum of digits. That's a cool problem. I like that idea. So visually try to see what image it is or see what number it is and then add it and figure out what it needs to be. That's cool. I like that. That's a neat thing. So what does he do? He's got his time distributed business. You don't show the training line. Why not? Why not? I don't understand why people don't want to show the training line. That's like the most important line. Add MNIST to whatever. Okay, show me your model. Random seed, you're doing this stuff, you're loading your data. Here we go. Yeah, run epics, sampling data when training. I don't know why you can't do this in the thing, but... so he's just exploding his data, I think. Examples per, max to add. Examples per. Initialize a training example of max num time steps. So it generates a random number of things to add together. Let's see. He grabs those particular images. And he's going to pass in. So he's just grabbing random images and he's going to have to add those to his output. So he's jumping them in directly, which is most unfortunate. So this doesn't do what I was hoping it would do. That is a major bummer. Alright, so this is still cool, this LSTM business. But that's not going to be the killer feature that I wanted. Where it would, given an input of the shape that I would normally think about, that I've got this for all these frames, like automatically look at the right sequences in order. But I do not think it does that for you. I think you have to assemble your sequences in the appropriate order. Or you have to assemble, like, the first data point is the first 8 frames. The second data point is these 8 frames. The third data point is these next 8 frames, and keeps a sliding window of it around. So it's probably not actually going to multiply my memory because it's already in memory. It's just a bunch of pointers in Python. But that's something that I don't want to have to fiddle with a whole bunch. So maybe I will not be doing that at this particular instance. Let me see, however, if I can... Did I get rid of my reshape? I got rid of my reshape. Silly, silly me. There we go. Let's do RS. M defined? I don't even know if M is defined anymore. Oh, so let's take out the time distributed for the moment. Just for the moment, that's all. Bring these back into the fold. And I want to see if the LSTM will essentially run the same way, and then I think we're going to call it tonight. We'll see what we get to in the future then. Is that right? Yeah, it should be right. Does that make sense? Oh, it does. Good, good, good. We can close on a note of not crashing my computer, which is always a plus in my book. And of course I screwed something up here. Screwed something up. What did I screw up? What'd I do? What'd I do? Just kill it. Just kill it with fire. Then I'll learn what I did. Image inputs. Alright. Let's grab all this stuff. Send that over. And I will learn very quickly what's not working over here. I will still import that stuff, even though we're not using it. Okay, convolutions are working okay. That's all, everything's hunky-dory. It's good, I got the merge, got the reshape. Oh, this is L, not R. That would be what the problem was. Guaranteed. Nope, almost. ES1 is not defined. Alright, where it went wrong. The dense layer did not work. Input 0 is incompatible. Expected ndim 2, found ndim 3. I gotta reflatten, apparently. Apparently. What the heck did I do here? Worked fine here. That's weird. That's really strange. Why did that work here and not there? That's awful, awful strange. So... yeah, that doesn't like it. Input 0 is incompatible with layer 3. That's wild. Absolutely wild. When this... here I went straight to the output. Alright, well, I will have to sort this out then, I think. Figure out what's going on with the LSTM. Why is it being different? Of course. We'll look at this just to see what's going on. What does it look like at the end here? Oh, pfft, right, because I've got one comma, whatever, below me. I don't know why I couldn't get away with this earlier. Well, how I got away with this earlier, but not now. Maybe something changed in one of the libraries. I don't know. We'll flatten that back out. Flat L. Yeah, that should be fine. Life is good. Okay, real quick. Compile, even though it doesn't actually compile. I hate that. Hate that it does not actually compile when I call for compilation. It's such a drag. Alright, we'll just get that to start running. Alright, my computer is about to, not my working computer, my laptop that I check the chat on is about to run out of battery, so I'm afraid I am going to have to cut things about here. And there's the oven. It is just about dinner time for me. I want to see this start training though. Hold on another few minutes, computer. Hold on. Did I push the... always make sure you hit enter enough times. I feel really dumb when that's the thing to like. Oh yeah, it's just waiting. Oh, so thanks for all the helps from Mr. Oguzakas. It was interesting to look at this time distributed layer, even if it didn't do exactly what I wanted. But I think like that's a better solution than what I did like a couple months ago with my font recognition, where I formed a graph model and just read in everything separately. Certainly that would be a lot more sane way to track it. And in fact, in that model, I guess... no, I have the same layer, same convolutions. Yeah, that would be a lot more sane way to do what I was doing there. So were I to do that again, I would definitely take a closer look at this time-distributed stuff, because you don't have to do quite as much silliness. But in this instance, I don't know that's going to be as critical, and it didn't quite do what I would have wanted in terms of saving me the effort of massaging my data. Alright, it's doing something. It's training. It's not throwing up on me. So, thanks for everyone coming out and watching tonight. We will be back again next week, I believe. Probably still doing self-driving car stuff. We may be looking at these RNNs more. We may have collected another data set. Who knows? We'll get there when we get there. Don't forget to stay safe in the data mines. Have a good night, everybody.